Elementary Algebra, Final Assessment 4, Review, Questions 11 through 14, Outcome 3, Notation. Question number 11 reads, Factor out GCF. This stands for the greatest common factor. So looking at this problem, 4x to the 12th power minus 8x to the 9th plus 12x to the 6th minus 16x to the 3rd. We'll first start with the constants, 4, 8, 12, and 16. Let's start with the smallest number and see if that smallest number will divide into each of the others individually. Because the largest number that will divide into 4 is 4. 4 will divide into 8 evenly. It will also divide into 12 evenly, and it will also divide into 16 evenly. So we know that we can divide a 4 out of each of these. So 4, 4, 4, and 4. Next, we see x's are available. The one with the fewest number of x's is going to be the one that determines the number of x's we can divide out. This is the last term. We only have an x to the 3rd power. This is the greatest number we can factor out. So we'll put an x to the 3rd under each one. So the GCF for this one was 4x to the 3rd power. So this 4x to the 3rd power has been pulled to the outside. When we look at the 4 dividing into the 4, it creates a 1. Then we have an x to the 3rd divided into an x to the 12th. When we're dividing and we're dealing with exponents, we subtract the exponents from one another. So 12 minus 3 leaves us with 9. So this is x to the 9th power. Carry down that minus sign. 4 into 8 goes 2 times. X to the 3rd divided into x to the 9th. 9 minus 3 leaves us with 6. So x to the 6th power. Carry down the plus sign. 4 into 12 goes 3 times. So then we have x to the 6th minus x to the 6th divided by x to the 3rd. So 6 minus 3 leaves us with x to the 3rd power. Then lastly, 4 divided into 16 creates a 4. X to the 3rd divided by x to the 3rd. 3 minus 3 is 0. If you remember the rule with your monomials, anything raised to the 0 power is equal to 1. So we end up with a 1 times a 4, which is still 4. They've simply canceled away. The instructions for question number 12 read factor completely. We see that we have 4 terms here. So we know that at some point we're going to factor by grouping. But before we do, we want to look at each of these and see if there's something that we can factor out of all 4 terms before we move on to the grouping procedure. We see here we have a 4, a 4, a 20, and a 20. When we look at our variables, this one has an x, but this one has an xy. This one has an x, but this one doesn't have an x, just a y. We know that we're not going to be able to pull out any variables, but we know that 4 will divide out of each one of these. So let's pull that 4 out. These have a greatest common factor of 4 that will pull to the outside. So we're left out here with 4 with an x to the 2nd to the inside, because 4 into 4 creates a 1. X to the 2nd carries down. Plus, again, a 4 into a 4 goes to a 1. So we just carry down the xy. Plus 4 into 20 to create a 5x. And then 4 into 20y to create a 5y. Next, we want to continue to group by continue to factor by grouping. We can do that by grouping out the middle terms with one another. So I've grouped the x to the 2nd power plus xy and the 5x plus 5y. So I'm going to come in here and divide out on this first binomial an x. So this x is coming to the outside of this bracket here. So what I'm looking at is an x left to the inside plus y. On this other one, I'm going to carry down the plus sign, and I'm going to carry or pull out a 5 out of each side. So I have a 5 pulled outside. I'm left inside with x plus y. I'm not quite done here with what I need to pull down. If you remember, earlier we had that 4 pulled to the outside there, so there's still a 4 sitting outside this entire thing. Next, I want to factor out the x plus y, x plus y. So I come in here and I factor out x plus y, x plus y. As I pull this x plus y out, this appears here. It's actually coming out with that original 4 that I already had pulled out. I'll just pull that 4 down. So what I'm left with up here that hasn't been canceled yet is this x plus 5. It pulls down. X plus 5. So now I factored completely. The instructions are not to solve, just to factor, so I'm going to stop right here. Question number 13's instructions read, factor. If the polynomial is prime, so state. When I look at this one, I see a trinomial in the form x to the second power plus bx plus c. In this case, I don't have a value in the a position other than 1. So I'm not going to use the a times c method. I'm simply going to pull out what's in the c position, which in this case is equal to a negative 18, and what's in the b position, which is equal to a 7. From here, I can still use the listing method to find a replacement term for my original. So I'm going to come in here and try a negative 1 times an 18 equals a negative 18. The reason I place the negative on the smaller number is because when I go to sum the two terms, or the two values, I want it to come out to a positive. So I have a negative 1 plus an 18 creates a positive 17. This isn't quite what I wanted, so let's move on. Let's try a negative 2 times a 9. This is also negative 18, but when summed, 2 plus 9 creates a 7. I've found my two values. Now because in this one I don't have anything in the a position, I simply create a pair of binomials. I look at this first position, which is x. I place an x in each one to take care of that x squared. Just broke it apart. And then I come back in and I'm going to put those numbers that I found in my listing method here. I have a minus 2, so I'll plug that in, minus 2, into my first binomial. I have a positive 9 plus 9 in my second binomial. I've completely factored. In problem number 14, the instructions read, factor completely if prime, so indicate. Here I have a trinomial, and this time the trinomial has a number in the a position. So I'm going to pull what's from my a position, which is a 9, and what's in my c position, which is a negative 8. And I'm going to multiply them together to get a negative 72. Now I'm going to pull what's in my b position, which is a negative 6. Now what I'd want to do is work my way down, finding a pair of factors that when multiplied together create a negative 72, but when summed create a negative 6. You could find this by using the listing method. For now though, I'm going to take you right to the answer, which is going to be a 6 times a negative 12, which equals a negative 72. So then a 6 plus a negative 12 is going to equal a negative 6. Here are my two factors. So I'm going to rewrite my original problem using the two new numbers to replace the middle term. So now I have a 9z to the second power minus, now this time I'm going to use the minus 12 over here, 12z. The reason for that is so that, if you remember from a previous problem, if we put a minus in the middle, we have to turn it to a plus. Well, if I just put that positive 6 in there, I don't have to do any rewriting before I group. So 6z minus 8. Now I'm ready to group. So I'll group the first two terms and the second two terms. And I'm going to divide out the greatest common factor. So in the case of the first one, it'll be a 3z. So I pull out the 3z, and this leaves me with a 3z minus a 4. Carry down my plus sign. Now I'm going to divide out here a 2. So I get a 2 to the outside. I'm left inside with a 3z minus 4. Last step would be to divide out that 3z. So I'll divide out the 3z minus 4 from both sides, 3z minus 4. So this gives me here a 3z minus 4 that comes out. What's left is the 3z plus 2. So that creates my second binomial, 3z plus 2.